Hi, everybody. Welcome. Thanks for joining this month's Tech Talk series. We're going to be discussing modernizing legacy web applications utilizing AI tools. For introduction purposes, I'm Joe Rafanelli. I'm one of the directors here, Technical Solutions at Innovatix Technology Partners, aka Microsoft. We are a leading custom software development company specializing in transitioning legacy systems to modern platforms. So we did a similar tech talk last year where we showed how AI accelerates FoxPro migrations. Today, we're going to take it to the next level. We are going to talk about legacy web applications. So it's going to be ASP Classic, ASP.NET, web forms, and ASP.NET MVC systems that still run day-to-day operations in thousands of businesses. We'll show how these applications can be migrated to a modern .NET Core Plus Angular stack using AI, specifically Claude Code, and just as importantly, how the new system can be automatically verified against the old one, screen by screen, which is very important in UAT. So glad to be joined again by Danish. He is one of our senior developers. He's head of AI migrations team. He's completed many migrations for us, has a great approach that he's about to show you. Large-scale modernizations currently in flight, which he's doing currently. He's brought a full record of demos to walk us through today, so hopefully everybody will get a good feel about what he's been doing. I'm going to let him introduce himself in a minute, but for admin purposes, I am going to ask him a series of questions, which we normally do, right? And then at the end, I'll ask the folks that have joined to ask some questions via the chat. So, Danish, I'll go ahead and give you a minute to introduce yourself.
Thank you, Joe, for the kind introduction. I am Danish Tahir, a technical lead focusing on modernizing legacy systems with AI at Innovatix. So earlier, a few months back, we demonstrated migrating a FoxPro application with some help from AI. Since then, the tooling has changed dramatically and the models have improved drastically as well. So agentic tools like Claude Code don't just suggest code anymore. Now they enable us to read an entire legacy code base, plan the work, write the new system, test it, and even operate a browser to verify behaviors. So today's focus is on legacy web applications in general, just like Joe mentioned, different frameworks. So these are systems that look modern enough because they run in a browser, but under the hood, they're like 10 to 20 years old. ASP Classic, web forms, ASP.NET MVC with Razor views, for example. So today I'll walk you through our migration framework, show you a recorded end-to-end demo, real legacy application based on ASP.NET MVC, getting migrated to a .NET Core APIs plus Angular at front end. So, and the part I'm most excited about to demonstrate today is the automated screen-by-screen verification of the new application against the running legacy application with the help of Playwright MCP with Claude Code. So approving parity has always been the most painful and expensive part of any migration, Joe. So that's the part AI has now genuinely solved, I believe.
I could definitely feel your enthusiasm. Hopefully folks will get something out of this session. Appreciate you, okay? All right, so I got an easy question to start. So it's already running in the browser, right? So folks might be saying, well, why migrate it at all? Like, what's actually broken?
It's a great question. Yeah, the great place to start,
Yeah.
Joe, because it still works is exactly what keeps these systems alive. And that exactly is what limits the business. So I'll mention a few things. First, they have actually hit a user experience ceiling. You simply cannot bring any modern UI into these frameworks. Rich data grids with instant filtering, sorting, charting, dashboards, responsive layouts that work on a tablet in a warehouse or on a vessel even. The post-back model of these web forms and the server rendering Razor model fight you every step, every post-back, every page load. So users compare every business app to consumer apps on their phone, and the legacy apps lose every time. Secondly, these platforms themselves are almost end of life, or I'll say actually are is in framework are actually frozen, security patches, third-party components, and frankly, developers who want to work on them are all getting scars every year of delay in migrating or modernizing these applications increases your risk and cost. Third, the architecture is sort of a dead end. The UI, business logic, and the data access are welded together. There's no API layer, which basically means no mobile app for you, no partner integrations, no automation, no AI features. So that the business logic is just trapped inside those web pages. And the fourth and the most important one that I would want to mention, uh, the the modern target that we have unlocks all of it with .NET Core Web APIs plus Angular. The business logic that you have lives inside a clean API. The web application consumes that API, and so can a mobile app, a customer portal, or any integration with any other application that you have in your organization, all from the same API layer. And on the front end, component app libraries like Angular Material and other CS tools give you a modern, consistent, and accessible UI essentially out of the box. So the business case isn't actually that the app is broken. It's because the app cannot grow, and the organization is obviously paying for that ceiling every day.
Those are some great points. And I'm glad you went into the details because I know some of the developers on this line probably really resonate with what you're saying. Key answer is, and you said it at the end there, you're not going to grow if you don't make these moves. So, but you definitely went into the detail for the other folks. I appreciate that. So walk us through the approach. When you take on one of these migrations with AI, like how does it actually work?
Yep, let's do the most important interesting part of this session today. Let's jump right into the demo that I've
Perfect.
prepared. I'll be taking you through a small video, as I said it in the beginning, where I will demonstrate how we achieved it, and we'll go step by step. Let me just start the demo. Yeah, you see my screen.
We do see it. Thank
So
you.
I'll first I'll say a few things about where we started, and how we are going to do it. So it would be a 6-step process, and I'll take you through each of the steps in that. And so we start from a legacy application. As you see, it's an ASP.NET MVC application with not so modern design, but something that works today. So this is a basic employee management system that we have right now. Um, I'll just take you through the basic process. You can see the employees list. You can create an employee. You can update those employees. There's some validation in place as well. So that is a basic CRUD application for an employee management in the legacy ASP.NET ASP.NET framework. And you see there's validation as well. But again, the UI you'd see is not so modern. So what we'll do in the first step is to translate and prove the backend works. So the Claude code would read the legacy application, controllers, code behind, business logics, SQL access, and would translate it into .NET Core Web APIs running against the same SQL database. So the data does not move. That's actually a huge de-risking decision. So let me take you through that. You see, I'm still running the operations on legacy just to show that, yeah, the searching works, the listing part works, and this is where we jump into the actual work. And this is actually, sorry, the SQL database and the stored procedures that are with the legacy application as well as the new application. So there you see those and some C data. So this is where the magic starts, the backend translation step. So you see, it's confirming that the legacy application is running. It's reading the legacy application, and it's started to create code for the new application. You see the controllers being created, repository files being created, and the new application is now running at the at that port as well. So So you see all the APIs for the CRUD application have been created, get, post, put, and delete. We can see those APIs in Swagger as well, where we can do some sort of testing as well. But before that, just giving you an overview of the code that has been created in this step, where the APIs were created, and this is the Swagger link where I'll just run one particular operation of getting the employees, and you see the employees are listed, right? Um, and then the second step would be to generate automated tests for those APIs and run them before even any single screen exists. So that's where we run, but we create those unit tests, and you see there were 33 tests that were created, and all of those passed. That's to make sure that the logic that was there in the backend of the legacy application is ported correctly to the new application. The X unit tests, yeah, you can see the details, and there was some a small issue found with the date time thing as well. That was fixed as well. And then we now we move to the third step, where it would build the modern Angular screens from the legacy screens, same fields, same workflows, but with a modern design system and modern components. So you see, it started creating the TypeScript files for employee and the relevant options, validators, etc. And it started the application as well to verify if it created it correctly. So see, it found a defect as well. Right now, this is without any backend wiring. So the custom, you see the front TypeScript code being generated against that as well. The employee lists, the employee forms, and the models against the entities all have been created, and you see the screens that there are as well. So just take it back. So you see it builds modern Angular screens. So the customer would now review and approve these screens before any wiring happens. This is deliberate. Changing a screen at this stage costs almost nothing. In traditional projects, UI feedback arrives at UAT when it's the most expensive. You see, I'm trying to create an employee here. The validations are there. I created the employee, it appears there. But if I refresh it, since the backend wiring hasn't been done, you would not be able to find that employee. So let's test data only right now, right? All right. So now we move to the one of the most important part. But before that, we will review the package, and it would create some documentation, and you see it's telling you what's in there, the add what's in the add employee section, what's there in edit employee, what's there in employee details. That's to make sure that whatever that we have built till now, it's in line with the requirements. So all of these details could be taken to the subject matter experts at the customer's end, and they could verify, yes, this is what we had in legacy, and yes, you are moving in the correct direction. Then, as I said, we move to the front-end wiring process. So the approved screens are then wired to the already tested APIs, and you see the code that we created in the previous step is now being modified to incorporate those APIs with the new these the front end application is being run to make sure front end application, you see this is being run to make sure that the steps correctly. Hit just to ensure the data persists. So that we'll see the employee that we have created. If we refresh it, we'll find that because now the firing has been done. And when you delete it, you would not be able to find it. So that's done. But the last and the most important part is to verify what we have built. And this, Joe, is the differentiator. We run the legacy application and the new application side by side, and Claude Core uses Playwright through MCP to operate both like a real user, screen by screen, comparing behaviors and producing parity evidence. And let's see the parity evidence. I'll actually be honest with the audience. The steps sound very simple, Joe, and you would say it as well that these are very simple steps. That's intentional. The framework that we are demonstrating here is very easy to understand. The crafts is actually what sits underneath it. The conventions, the guardrails, skills, and the verification harness that we have built around Claude Code over many projects. That's actually our kitchen, and today you get to taste that food. So you can look at it, all the scenarios that it has listed. It will show the legacy results versus the new app results with the screenshots. And then the next step, Joe, I'm going to show you those screenshots as well. See all the scenarios, like deleting an employee, editing an employee's job title, everything's listed there. Then here is where the screenshots come. You see the creation of an employee in legacy versus creation of an employee in the new system. So even the validation, you see the email address is already in use versus the validation in the new system, the termination date validation. So everything that's there in legacy, it's compared against the new systems with all those screenshots. So that's where the magic happens, the verification step. Yep.
That looked great. I'm glad you pre-recorded that because I'm sure that would have taken a lot longer. But that I like the way you went through all the screens, and I'm sure that the folks that are techie folks really resonated with them. Like I said before, thank you for putting that together and explaining it. And like you said, it's there's steps, and they maybe seem easy, but it still needs expertise, like yourself. You know what I mean, to complete these steps. So appreciate you disclosing all that. All right, so let's move on to my next question. So there is some fear in terms of, I don't know, maybe you got 15, 20 years worth of legacy systems and the business rules, right? That's within so how do you make sure, you captured everything, right? How do you make sure the old one acts like the new one? What kind of verification do we do there?
This is a very interesting question, Joe, and this is what I showed and tried to demonstrate in the last step. It's actually where migration projects traditionally bleed money and effort. Armies of testers, spreadsheets of test cases, months and months of UAT, and even then, sign-off is based on sampling and trust. So here's what has been changed. Playwright, a browser automation tool, is now available to Claude Code through MCP. That actually means that AI can operate a running web applications the way a human user does, a human UAT user does. Open pages, fill forms, click buttons, read what comes back, as we demonstrated through the validation messages that you saw. So in our final phase, the parity check that you saw, we run the legacy application and the new application side by side, and Claude Code drives both of those. Same inputs into each, then it compares the outcomes, the records that are created, the validation messages against the hire date versus the termination date, the email one that you saw, the calculated values, search results, all of it. So three, four things basically fall out of this that the customers love. First is the screen by screen parity evidence. So for every screen, what was tested with what input, what each system did, pass or fail. And you saw in our demo everything was passed, and then we showed the screenshots as well. So sign off actually stops being a leap of faith and then becomes a review of evidence, the evidence that we demonstrated as well in this short example. Second thing is the behavior discovery. Running legacy application is the only true accurate documentation. Joe, there isn't any documentation, huge piles of documentation in these legacy system. Driving the legacy application surfaces the undocumented rules, the quirks nobody wrote down. So those are verified, not lost. And then eventually, as I said earlier, compressed UAT. When the customers team start testing, they get a head start. The obvious gaps are already found and fixed. UAT becomes the confirmation phase and not a discovery phase.
I lost you there. Can you hear me okay?
Yep.
Okay. Okay. Excuse me. So let's talk numbers, right? So for the business guys out there, I'm sort of wondering how much money we're saving and how much time are we going to be saving. I'm sure you got some percentages that you can share, with the audience. Appreciate that.
That's a question that we always get, Joe. So let's take a representative mid-size uh, business application, ASP.NET MVC application with roughly 100 screens, around 60 controllers, SQL Server database, and around 15 years of accumulated business rules. The traditional rewrite is a 10 to 12 months modernization period with a team of about 8. And then critically, around a third of that budget is around verification, writing test cases, manual regression, and extended UAT periods. Now with the AI-driven approach with our framework, the same, actually same scope lands around 5 6 months around a team with a team of 4 to 5 people only. That's roughly 45% cost reduction and half the calendar time. So the question would be, where do the savings come from? Translation throughput is the obvious one, obviously, but the biggest single lever that we have with this approach is the verification phase. What used to be a third of the budget in manual testing becomes an automated, repeatable parity run. And it's repeatable. Every time something changes, we rerun it. Regression testing in that approach, with that approach, effectively becomes free. But one honest caveat: every legacy system hides surprises, reports, integration, stored procedure logic. That's why we always start with an AI assisted assessment and a pilot. One module taken through all 6 steps into the same 6 steps that I demonstrated here. And the pilot proves the pattern and calibrates the number before anyone commits to the full program.
I mean, that sounds amazing. If you can save that much time and that much cost. I know it's not all AI generated. There's human interaction. Humans have to understand and, you know, be the experts like I was saying before, but that's pretty significant. And I know what we've done in the past is, requote clients if they want to do migration, or prospects, when they want to do migration, and there is that significant cost savings. So hopefully everybody heard that, and it was interested in hearing that. So you described something that sounds almost hands-free. Not exactly, but almost. Is there really no code? Where do people fit in, and what are the risks? People typically ask about the risks.
Yeah, that's a common question with AI, actually, Joe. So I'd call it low touch, but no, not like I'll not call it no brain. So the
Okay.
AI does the heavy lifting, but people basically make the decisions that matter. The architects set the target patterns and conventions the AI must follow. The senior engineers review the high risk logics, anything touching money, tax, compliance, or any calculation that are important. All of those get humanized always. Then the customer, they approve the screens at the gate and review the parity evidence. So they are in the loop by design. And the two moments that their input is cheapest and most valuable. So, and regarding risks, Joe, the classical fear with AI generated code is that it confidently gets something subtly wrong. But our answer is structural for this. The verification phase exists precisely to catch that. When the new system is checked screen by screen with against the running legacy application, even a subtle behavioral difference doesn't survive to production. It shows up as a red line to the parity report. And you saw the parity report that we showed had everything green. But if there was something highlighted, we would certainly go back and fix it. So because the data never moves, it stays in the legacy application. The legacy application stays frozen and runnable. So the rollback risks during this program are almost zero. The cutover happens once only when the evidence says it's all ready.
Perfect. Thank you for all of that. I want to open it up to questions for folks. Let's see what we have going here. See if we can get a few here. All right. The first one, most of our business logic lives in SQL stored procedures. How do you handle that?
So in that case, in this particular scenario as well, Joe, stored procedures are treated as first-class source code. They're read, understood, and either preserved and called from the new APIs or translated, depending on what the customer's strategy is. Either way, they are covered with the same testing and parity verification. The logic is in the logic in the database is not a blocker; it's just another output, another input. Actually, sorry.
Okay, perfect. Thank you. Okay, I got another one here. What's the rollback plan if something goes wrong?
Yeah, just like what I mentioned earlier in the last part of the discussion, the beauty of this approach is that the rollback is built into the architecture. The legacy application is never modified, stays frozen and runnable on the same database throughout, even during this modernization period. So until the very last day, until the cutover day, going back means simply continuing to use the old system. And cutover itself only happens when the parity evidences say the new system is ready against the legacy system.
Thank you. Any other questions? Okay, take one more here. Our system has almost no documentation. Is that going to be a problem?
As I said earlier, Joe, so it's very normal in the with the legacy systems modernization, and it's exactly why we are verifying against the running application rather than any documentation. So the live legacy system is the only documentation that's guaranteed to be accurate. Between the AI-driven code analysis, playwright-driven behavior discovery, and the short sessions that we'll have with your subject matter experts, missing the documentation or the missing documents stop being blocker. That's how we run any migrations, any modernization.
Makes sense. I definitely knew that we don't get a lot of documentation. I totally get it.
Yeah.
Let's see, anything else? All right, we're going to go ahead and close the session. Thank you, Danish, so much. That was excellent. Oh, I have some question here. Does it handle banking clients which uses WebSphere such as IBM was our MQ product, which are traditionally on-prem?
Oh, that's a loaded question, Joe. So that's an added layer of guardrails. Yeah, the framework is handled to is built to handle the normal migrations. But yes, we can add more steps, more guardrails to handle migrations, like the systems mentioned in this question.
Oh, perfect. All right. I'm going to go ahead and close it out at this point. Anything else? Any other questions you can send to us on an email? Okay. So, Donis, thank you so much for your time and expertise and going through all of the examples. Great questions from the audience as usual. So, the session showed that legacy web apps, ASP Classic, Web Forms, ASP.NET, MVC still work, but need modernization due to user experience limits, end-of-life platforms, and architecture that can't support mobile integrations. As we saw, Danish presented 3 phases, right? 6 steps, AI-driven framework, translate and prove the back-end design and improve the front end, then wire and verify. So that was the verification process. We did a full migration example showing moving to .NET Core and Angular, including an automated screen-by-screen verification of the new system against the legacy Playwright powered by Claude Code. Key outcomes, significantly shorter timelines, about 45% lower cost when we showed the example, and customer sign-off base evidence rather than trust, right? So it's definitely going to save a ton of time. Next step offers, for those with legacy apps, a low-risk pilot, a new single module to demonstrate the framework on their code contact. So if there's folks that have questions or want us to take a look at their code and want to look at a POC, we're happy to do that. You're going to see my contact information in a second. At this point, I want to thank everybody for their attention. And I want to wish you guys a good day. And we'll talk again next month in our next session. Thanks, folks. Take care now.